What's up, Chem fam? This is Lit Chemistry, where theory meets excitement and concepts spark with clarity. So, today's topic is electrochemistry. We are going to solve a problem. So, calculate the cell potential and equilibrium constant for the redox reaction given below. So, this is the redox reaction given. So, let's find the solution. So first we are going to write the Nernst equation formula, that is E cell is equal to E naught cell minus 0.05915 divided by n log, we have C D divided by A and B. So this is the Nernst equation formula that we have. In this formula, E cell is the actual cell potential under the given concentrations. It is the final value that we are trying to calculate, as well as we have E naught cell, that is the standard cell potential. In our problem, the standard cell potential E naught cell is 0.56 volt. It's already given, and the number 0.05915, it is a constant for calculations using log, usually base 10, and the number n, this number is the number of electrons transferred in the redox reaction. For example, now here we have Sn4 plus, it becomes Sn2 plus 2 electrons, or Cr2 plus, it becomes Cr3 plus 1 electron. But after balancing, 2 electrons overall, see, we have 2 electrons overall, so n becomes 2. So we divide by n because potential depends on electron transfer. Then we have log. Log is nothing but logarithm of the reaction quotient. Then at last we have this part. This part is called as the reaction quotient, where products are in the numerator and reactants in the denominator, each raised to the powers of their coefficient. These are powers of their coefficient. So let's start solving this sum. So let's write E cell, okay, is equal to E naught cell. E naught cell is given to us 0.56 volt. So I write 0.56 minus this, we write as it is 0.05915 divided by n. N will be 2. Here a simple trick to find n will be the number which we have with which we have balanced, that will be n. So here we have 2 and 2 with which we have balanced this redox reaction, so n will be 2 log as it is, and CDAB. How to find this reaction quotient? So let us assume for now this as A, B, C, and this one as D. So C, A, B and C. In C we have Sn2 plus, so I write Sn2 plus. In D we have Cr3 plus, so I write Cr3 plus, but it is balanced by 2, so square. In A we have Sn4 plus, and B we have Cr2 plus. and this is balanced by 2, so square. So 0.56 as it is minus 0.05915 divided by 2 log as it is. So in the place of Sn2 plus we have 0.065 and in the place of Cr3 plus we have 0.024 we have square, we write the square as it is, and in the place of Sn4 plus we have 0.10 and in the place of Cr2 plus we have 0.15 and square because we have balanced it with the number 2 square. So next step, 0.56 as it is minus 0.05915 divided by 2 log as it is. So now this is the important step. First we have to multiply these both and these both, and then we will be squaring it. So in order to multiply, we use the scientific calculator. 0.065 into 0.024 we get 1.56 into 10 to the power of minus 3, can write it like this, and square divided by, we multiply this now, 0.10 into 0.15 we get 0.015 and square. Okay, so next step, we write this as it is, 5915 divided by 2 log. So now what we do is we square this again using the calculator. 1.56 into 10 to the power of minus 3 will okay, so I square this, I get 2.4336 into 10 to the power of minus 6 divided by, we square this, 0.015 whole square, 2.25 into 10 to the power of minus 4. Okay, so next step, we write these things as it is, 5915 divided by 2 log. Now we divide this number, that is 2.4336 divided by 2.25 we get 1.0816 into 10. Now 10 to the power of minus 6, when this minus 4 goes up we have plus 4, so minus 6 plus 4 which will be minus 2. See, here there is minus 6 minus 4. When we divide 10 common, we take it as common one term, and minus 4 goes up, it becomes plus 4. So minus 6, which was this one, and minus 4 goes up, plus 4, minus 6 plus 4 minus 2. Then next step, 0.56 minus 0.05915 divided by 2 log. Now we multiply this in order to simplify it completely. 1.0816 into 10 to the power of minus 2, so I get 0.0108. After point we only take 4 numbers, 4 values. Next step, 0.56 minus 0.05915 divided by 2. Now we take the log 0.0108. So we have log option here, log 0.0108, that is minus 1.9665. We only take 4 values after the decimal. So now in the next step, what do I do is I divide this. So I have 0.56, and if I divide this, I have minus 0.05915 divided by 2. That is, I get minus 0.029575. So minus 0.0295, and this will be mine in multiplication form. So because it was in multiplication form here, it will be in multiplication form. So I put a bracket here and I write into minus 1.9665. So next step will be 0.56 as it is, and we multiply these both terms. So minus 0.0295 into minus 1.9665, that is plus 0.0580. Minus and minus becomes plus. So now we add this. Finally 0.56 plus 0.0580, that will be 0.618. So we take the E cell from here. E cell will be 0.618, and the SI unit will be volt. Why volt? Because electrical potential is measured in volts, which is the SI derived unit for electric potential difference. So E cell is equal to 0.618 volts.